check. Sound check. Guys, can we hear the end? Perfect, perfect. Okay, good afternoon, everyone. So I'm Abinash, and welcome to my talk on high-performance image upload. I promise you the talk will be better than the title. I promise you that. Okay, so a little bit of introduction about myself. I'm Abinash. I am a UI engineer in the Flipkart ads team, and previously I was a core member of Flipkart Lite. I am a gamer, a big-time sneakerhead, and a biker, and you can find me at TwistedFolk88 on Twitter. Now, I want to start off with a very serious note, and I would really like to have your undivided attention. Perfect. Now that I have your attention, I want to take a moment to brag about my new sneaker that I'm wearing today. So these are the Adidas Marvel collaboration with Donovan Mitchell. It's called Dawn Issue 1 in the amazing Spider-Man colorway, and that's the name of the sneaker, yes. Okay, so let's jump right in. What are we trying to solve here? So when Flipkart Lite introduced this feature, which allowed our customers to write reviews for the products that they had purchased, we wanted to extend this feature by allowing them to upload the photographs of those products as well. Well, more or less, this is what the talk is going to be. And for the next 25-30 minutes, I'll be taking you along with my team's journey as to how we approach this particular problem and how we try to solve it the best possible way that we thought of. Okay, so let's take that statement and start breaking them into requirements that engineering can start solving upon. The first thing is we need to validate that image. Okay? The second thing is we needed to handle something called as orientation. We'll get into that in too much detail, but in some time. Then we also had to think about how can we optimize the network footprint so that the upload footprint, the network performance is also not compromised. And then finally, the incessant demands from our product that say, hey, can you still do something better? So let's do this. We all are here, you are here, I'm here. So let's start a brainstorming session as to how we can approach this particular problem. It could be given to anybody. So let's see how we can solve this. So the first thing was that we needed to validate the file. It's not that difficult a problem, but we could have gone with the extension. And actually, in browsers, the MIME type and the extensions are close-related. The browser actually doesn't put in a lot of thought in it. Sometimes the operating system actually does not expose this MIME type, in which case we actually have to start reading the file, the first 4 bytes, and we find something called as magic numbers. Now, these magic numbers are actually a pattern of bytes, which basically tell you what could be a potential MIME type of this particular file. But the second thing was we needed to handle orientation. Okay, so most of our digital cameras that we use, they have a lot of sensors. They collect a lot of metadata about the image that we are trying to click. Now, this metadata is also injected as a part of the data along with the image. There are a lot of sensors, like they collect information like the location, the focal length, the name, make, model, and all of that. Orientation seems to be one of those properties. Now, most of us, maybe all of us here, we're not alien to this orientation property. We know at least 2 of them, landscape and portrait. But technically, there are 8 possible values for this property. We will not be getting into the details of all these 8 possible values, but this is just for our information that there exist 8 possible values. But to understand how this metadata works, how this metadata is put into the image, we need to understand something called as EXIF. Now, EXIF stands for Exchangeable Image File Format. Wikipedia defines this as a standard that specifies the formats for images, sound, and ancillary tags used by digital cameras, scanners, and other systems handling image and sound files recorded by digital cameras. Okay, in a nutshell, EXIF says what, how, and where are we going to put this metadata alongside with the image. There's a big caveat here, though. This EXIF data that we're talking about, it is potentially a property of TIFF, which is the tag image file format, and JPEG images. Most of the digital images that we have, let's say on our photo, like the photos that we take on our phones, they're all JPEG. So it actually makes a very good use case that we need to handle this. Cool. So let's take an example of what this metadata looks like to a human readable eye. So on the left, you have an image which is tilted for a reason. But on the right, we have a table which describes some of these values in the XF. For example, the make, the model, the orientation that we were looking at, the ISO, shutter speed, focal length, and a lot of these. Now, to understand how we can work towards and why these things happen, we are going to invest maybe just a minute on how cameras work. I promise you, this is not JavaScript. I know that. We are all here for JavaScript. But we will jump back into the JavaScript realm very soon. So when cameras save a photograph, they have just one rule that they follow. The top of the camera needs to point to the top of the image, and only they continue to save. So here we have a 3x3. And if you focus on the first column here, so we have 3 rows. So the first column has camera view, which basically says, when you click the photograph, how was the orientation? What was the orientation of the camera? The second row tells you encoded JPEG. What did the camera do before saving the image? And the third row basically tells you screen view, which is basically what does the screen, which is rendering the image, what should it do so that it renders the image in the orientation that you clicked in the first place? So let's understand this with some examples. So let's focus on the second column here. First row, we had the camera where the top of the camera was actually pointing to the top of the image. We clicked the photograph. The camera said, everything looks fine. I don't need to do anything. And the screen view also said, hey, the camera is not telling me to do anything. I'll just go ahead and render it as it is. Now, let's go to the third column. First row, what you did was you tilted your camera 90 degrees clockwise and then clicked the photograph. Now, the camera says, no, this is not going to work for me. What I am going to do is I am going to rotate this image 90 degree anti-clockwise and then save it. Now, the screen view needs to be told that, hey, I have rotated, the camera says, hey, I have rotated this image 90 degrees anti-clockwise, so you should rotate it back by clockwise 90 degrees so that the orientation matches to how it was clicked in the first place. Whew. Now, this doesn't sound easy. And when we first saw that this is how cameras work, we were thinking that, do we have to do all of this? Is there something that the browser gives me so that I do not have to go through all of that? Actually, the browser does. And that comes as a part of not even JavaScript, but as a CSS property called image-orientation. And if you set the value of this CSS property to from-image, it is actually going to enter into the image, file the EXIF information, and extract the orientation, and then render it correctly. But given the not so profound support of this property and the fact that most of these properties are actually getting deprecated, we realized that we have to take matter in our own hands. So fine, let's go ahead and start extracting this information. So we are going to read the file. We chose to read as an array buffer. And then, depending upon whether the EXIF information is present or not, where it is present, how big it is going to be, we clearly understood that this is not going to be easy. This is going to be a slow process. Something like this, we just have a file reader, and we instantiate it, we attach an onload, and then we read it as an array buffer. Very simple. Now, without having any engineering optimization, let's just run this with whatever we have learned till now, and let's see how does this fare. So I want you to focus on the add image button that appears at the bottom. If you click on this, you see that the bottom sheet that appears, it took too much time. We can go ahead for another cycle. So we selected a few images here. Now we tap on add image again. You see that the bottom sheet did not respond in due time. That makes sense because we're actually running a lot of code on the main thread, and that's actually preventing the main thread from handling other things like user interactions. Now, what could be the most prudent solution to solve this problem? Bring in a worker. So let's bring in a worker. We do the same thing. We add again, and this time the bottom sheet appears much faster. Again, very intuitive solution because we delegated a lot of work from the main thread onto a worker thread. So this is supposed to happen. This is fine. But nothing comes for free. When we did that delegation of the work from the main thread to the worker thread, we added a bit of penalty that the application now has to pay. So let's understand what the penalty looks like. So let's understand what this cost of the worker that we just introduced into our ecosystem, what does that look like? The first thing is, there is a cost associated when you create or destroy workers. Now, to me, in my opinion, although there is a cost associated, in my opinion, this is not a very pressing issue. I think with the help of decent engineering, we can actually solve this. How? Maybe instead of creating workers and destroying them on the fly, we could have a pool where we can have a set of workers which are reused rather than created and destroyed. So this, in my opinion, is a controllable and not that pressing a problem that we needed to solve. But then what was that problem that we needed to solve? So when we said that we wanted to delegate the work that we wanted to do on the main thread to a worker thread, we also have to give the data that the worker needs to work on. Typically, the passing of this data between two contexts, or let's say two windows or two threads, works via the post message API. Now, post message API traditionally has worked just by doing two simple steps. It would serialize on the sender realm, and it would deserialize on the receiver's realm. The important thing to understand here is that the post message API, it does the serialization via the structured clone algorithm. Now, structured clone algorithm is one of the most efficient ways for deep cloning objects, which also have complex data structures like dates, regular expressions, maps, sets, anything. Usually, such serializations via string serialization, let's say JSON.stringify, usually fail. So if you have a use case where you actually need to have such cloning, but we have complex data structures, structured cloning is the way to go. Now, this is exactly where our problem was. The images could be large, they could be in MBs in size, so we were thinking that, okay, this is becoming a bottleneck for us. This communication of the data between the context, between the threads, is actually becoming a bottleneck for us. Can we do something to get rid of this? And the answer was yes, we can. And that comes in the form of something called as transferrables. Now, transferrables, let's go with the definition first. It says that it's an interface that represents an object that can be transferred between different execution contexts like the main thread and a worker. Okay, so when we were discussing about the structured clone, it has the word clone in it, which potentially means that the structured clone is actually going to do a deep copy of the data and then work on it. But what if we have a detachable entity that can be detached from where the control of that entity can be detached from one thread or one context and can be provided to another context. For example, here we have two contexts, T1, T2. Let's say we have two threads as T1 and T2, and the box in black is basically the data that we wanted to operate on. Now, instead of copying this data, what I can also do is I can transfer the ownership of this memory block from T1 to T2. This is good because having a detachable entity makes you avoid the structured clone, which basically makes can make post message slower. So to address this, our post message API was extended, and we had a third parameter, or the second parameter in case of the usage, and that took an array of such transferrables. Now, transferrables works, they do. We used transferrables on a 1.722 MB sized images, not relatively larger, but not relatively smaller either. And the numbers are very self-explanatory, they work. And in my opinion, transferrables work better if your data that you want to transfer, they are more of blobs or file types rather than some simpler data structures, because in those cases, I think it is much, much better to do a string serialization via JSON.stringify rather than having the heavy lifting via transferrables. So this is the final output that we have. So on the left, if you remember, we saw the tilted image. And on the right is basically on the thumbnail component, we have the same image, which actually goes via this EXIF extraction, and we take the orientation property out of it, and then adjust the image or the thumbnail in the thumbnail component. Works. Now, the second thing that we were discussing about was how do we work on the network optimizations. We wanted to have an upload footprint which actually doesn't bother the customer. Why so? Because our customers can upload more than one image in one go, so we did not want this process to be really, really slow. So what we did was we tried to take this one step at a time, and we thought that, okay, let's try to do resizing of this image on the client, and let's see what happens. Now, resizing or resampling is basically a lossy operation, where it is basically an interpolation algorithm where you take a set of pixels, and you replace those pixels with a single pixel whose value is more or less matches the pixels around. Because we are replacing pixels, we lose data. Hence, there's a permanent dent on the quality of the image. It is irreversible in nature. So now, we try to do this via canvas using a regular canvas resize. Now, the browsers that they do interpolation when we use canvas to do this directly is linear. The algorithm that the browser uses for the resampling is actually quite linear. It's actually the linear interpolation algorithm, which does not give you the best of results. To work around this, what we did was we tried something complex. And we used something called as the Hermite resampler, which is a bicubic instead of the linear. And it is faster and it is smoother. Some other algorithms which we tried was bilinear and the nearest neighbor. Nearest neighbor doesn't give you really, really good results. It actually adds a lot of dent to your image. Bicubic is not that fast, but it gives you good results as well. So also depending on the fact that this was not exactly our area of expertise, I would like to bring that out, we settled with a bicubic algorithm like Hermite resampler. To just show you what this looks like, what we do is that we take the array buffer that the user uploaded, we run it through the resampling, and then we run via the Hermite resampler to actually have an optimized array buffer which has gone through some level of damage, but it gives us a decent reduction in the payload size of the image. Once we have this, we can use it, whatever, if you want to use it on the UI to render, or whether you want to just upload it to a server, that's the developer's call. But one thing I want to reiterate here is that these operations critically dependent on the Canvas API. All of these operations actually ran on the Canvas. So in the end, this is what it looks like. On the left, we have the original image, which hasn't been touched. And on the right, we have the image which actually went via the resampling. If you notice, the area around the whiskers, the eyes, and the jagged edges of the leaves, you can see there is some amount of damage in the picture. And that is because of the resampling. Cool. Now, since the beginning, let's go back 15 minutes. Now let's go back 15 minutes, think about it. We have been talking about this one thing that we wanted to keep the main thread free because we wanted that to work only on user interactions, and all of the other things were supposed to be delegated out of it. But since the last 5 to 10 minutes, we were discussing about resizing and resampling, and we consistently said that it depended on the Canvas API. Now, Canvas is a DOM API. If you truly want to have a truly multi-threaded architecture, how do we ensure that we do not do these operations on the main thread as well? Now, the answer to that is in the form of something called as off-screen canvas. Now, to simply understand off-screen canvas, we can think of it like, imagine you have a DOM canvas element and the set of capabilities of that DOM canvas element. All off-screen canvas did was it decoupled the capabilities from the DOM element. Now, because the capabilities are now separate, I could use these abilities, these capabilities, anywhere I want to. Now, that anywhere could be another context as well, like a worker. Now, there are two use cases how we could use off-screen canvas. One, the simpler use case, which actually fits our bill, is that I have nothing to render on the main thread, but I only want to delegate some heavy lifting to the worker thread. In that case, I could do something like this on the top, where I could just go ahead, initialize the off-screen canvas, and then just work on it as if it were a typical DOM canvas API. I just want to call it out that not all the APIs are named similarly, but more or less, yes, they do. But the other use case is a bit tricky, where you have something to render in the UI, but you don't want to do the heavy lifting on the main thread. So in that case, what we can do is we can actually get hold of your DOM canvas element. From there, we could actually create an off-screen canvas element, and that is done via this transfer control to off-screen API. Once we have the off-screen, we can then do a post message and then send that off-screen canvas to the worker, and then the worker can start working on it. The brilliance here is, though, that the off-screen element that is generated via this transfer control to off-screen is a transferable object. And if you remember, transferables will help you avoid the structure clone because they work via a detachable memory entity where the context can be passed between two threads. So this, combined with the power of transferables and post message, we were able to have a much faster transfer between the main thread and the worker thread. So let's see this in action without the off-screen canvas. We selected a few images. We go ahead and select a few more. And if you see, these thumbnails still haven't arrived. Why? Because there's a lot of work which is running sequentially because the user selected more than one image, and it is all running on the main thread because it's a Canvas API. If we do the same thing, but with off-screen Canvas, this is what it looks like. So we went ahead, we selected 3 images, we added a few more, okay, and you see that the thumbnails this time have appeared much faster. Because now we have actually a lot of parallel processing going on because we're not executing each image's processing in sequence, and rather than we're executing them in parallel. So this is the benefit that we got by actually offloading the resizing and the resampling off of the main thread. In a nutshell, this is overall what the architecture looks like. So whenever the user uploads an image, what we do is we send the control to a worker pool. Now, if you remember that we were discussing about there's a penalty associated because we introduced a worker in the first place, and we said that that is a solvable problem because we wanted to use a worker pool, and that is what we did. So every time the user uploads an image, we spawn 2 workers. One, which goes ahead and extracts the orientation property from the EXIF metadata. The second worker, which runs in parallel, which goes ahead and does the resampling of this image and gives it back the data. Now, these 2 run in parallel because they are actually not related. Their output either isn't related. When the first worker, which extracts the orientation property, comes back, the thumbnail component can start rendering that image with the current orientation. But when the second thread comes back with the updated array buffer after resampling it, we can just go ahead and upload the image onto our servers. So this is exactly the overall architecture of how our customers upload images for their reviews on Flipkart Lite as of now. Now, at this point in time, I thought, and my team thought, that we have done enough. We have, I think, achieved a few set of things that we aimed at, and we were quite happy, quite happy. But I was having this conversation with my Android counterpart, my colleague Naresh, and he told me that, you know what, we do all of this that you do, but apart from that, before sending, we encode our images in WebP format and only then send it to further reduce the payload. Now it's like, no, this is a dead end for me. There is nothing I can do to match up to that. And I was like, okay, then maybe we can stop. Then it clicked to me that, yeah, we can't do it, but in JavaScript. What if we use something else to do this? And that is where I started to experiment with WebAssembly, where we wanted to use a non-JavaScript language to code our functionality, but we ensure that that functionality or that feature runs in the browser. Now, WebAssembly is basically a type of code that you can consider. It is an IR, it is an intermediate representation. And the way this works is we choose a low-level language, for example, C, C++, Rust, because these are the languages for which WebAssembly provides a compilation target for. And once we have coded our program, for example, in our case, we chose C, and we used Google's libwebp library for encoding the image into WebP format. Now, once we have the C file ready, I have to somehow send this to the browser, but that is sent in the form of a WebAssembly or the WASM file. To do that, we have battle-tested tools now, which are build-chain tools, and for that, we use something called as mscripton. Now, mscripton is a tool that takes in your file, your code that is written in a low-level language, and what it does is it spits out 2 files. One is a WASM file, and the other is a JavaScript file. Now, this JavaScript file is like a glue file between the WASM realm and the JavaScript realm. And just to add a little bit of details here, our browser virtual machine right till now only understood JavaScript. But with the introduction of WebAssembly, now our browser's virtual machine will now also understand and compile WebAssembly. So this is an extension to the browser virtual machine implementation, and that is how we are going to send this WASM file. So what we do is we take this JavaScript file, which is spit out by mscripton, put it in our application, it goes ahead, downloads the WASM file, and then you start communicating. Now, there's a typical question, a follow-up question that comes up that, hey, but is it faster than JavaScript? I personally feel that this is not the best question to ask or maybe answer. Why? Because it's not about whether WebAssembly is faster or not, but it is about predictability. I won't get much into details because I'll be running out of time. So in the interest of time, what I can only talk about right now is the fact that when your code executes in the virtual machine that the browser runs, so you take the code, you parse it, you have an AST, and then you compile it into your machine code. After that, for example, let's say we take a runtime like V8. So this is a picture of snapshot of how code is executed in a runtime like V8. Now, V8 has, apart from an interpreter, it has a just-in-time or an optimizing compiler called the turbofan. Now, this turbofan compiler is basically, its work is to compile the hot code, or maybe the code which is more often used. Now, the optimization of that code into high-performance code by turbofan assumes that the code which is sent to it by the interpreter, called ignition, is right. Now, ignition makes a few assumptions while interpreting the code and pushing out the interpreted code to turbofan. If at any point in time, turbofan says, you know what, these assumptions don't hold. I am not going to compile this code into a much more faster code. So it goes back to ignition and asks ignition that, hey, why don't you go ahead and reinterpret this code? This process is called a de-opt. It's a de-optimization. This typically happens with all of our code. JavaScript does suffer from the problem of de-optimization. But the advantage here with WASM is that WASM does not go through this process. WASM, in the browser's runtime, it actually goes via a compiler called liftoff. Just to draw a parallel here, ignition is an interpreter, while liftoff is a compiler. Now, when WASM goes via a compiler, it is not checked line by line, but rather the browser actually has a 60,000 feet view of what this code is and how it is going to be used. The output is actually way, way more performant, and the browser ensures that will never be a de-opt in case of WASM. So the difference that we see here is JavaScript code can be de-opted, while WASM code will never be. So to take away from this is that it is not about whether WebAssembly as of now is faster than JavaScript or not, but the fact is that WebAssembly is always going to be predictable than JavaScript because it does not suffer from de-ops. So with this, I would like to give a shout out to a few set of people who have helped me with this project, especially to Inayat. Inayat is sitting here. So he worked really hard with me on this project. And I would also like to give a shout out to my design people, Tirna and Aman, who actually helped me with the design of the slides. They actually stood with the color triers that are actually used in the React India website. So yeah, that's all. That's all from my side, guys. Thank you. And before signing out, I would like to say that this is my first ever talk on such a large podium. And you have been an amazing audience and a very motivating audience, so I couldn't have asked anything more than this. Thank you. Thank you.
This video recording was brought to you by Twilio. We allow you to integrate different means of communication such as video, chat, or SMS into your React applications. If you want to learn how you can send SMS directly from a React chat, check out this video on the right or go to our Twilio YouTube channel. And if you want to watch another React India talk, we picked one out just for you over here on the left. Thanks for watching.